The simple equation below describes some reaction to dilute acids used in laboratory. So nitric acid plus an alkali A gives potassium nitrate plus water. So we have to originally know where on earth do we get the alkyl from. So the alkyl comes from always in the salt, the start of it, so potassium. And then alkali is always hydroxide. Then the next one is base. So a base can be a hydroxide or an oxide. So we know it has to be copper oxide or copper hydroxide. So we've got down both of them here. So the formula here as well of potassium hydroxide is KOH. Double check yourself. So it's K plus OH minus back of the periodic table because hydroxide's there. Remember, do not look at the front of the periodic table. You won't find hydroxide. Hydroxide is the back. Then we have copper hydroxide, Cu. So we know copper at the back, Cu2 plus. Hydroxide's OH minus. So what we do is put brackets around it. Cu bracket OH bracket 2. Make sure you put the brackets around the OH, because if you just put 2 that way, it just means 2 hydrogens, not the 2 oxygens as well. Then what's the difference between an alkali and a base? So I'm showing you here as well, copper oxide CuO. So an alkali is a soluble base. Both reactions are involved in neutralization. Write an ionic equation including the state symbols for neutralization. So remember, this is the one that you know anyway. You've got your acid, so it's H plus aqueous from your acid, OH minus from your alkali or your base, and then it gives you H2O liquid. So for this next reaction, we're trying to do nitric acid as strong acid, so it fully dissociates in to its ions, so it's just hydrogen and nitrate, which is NO3 minus, which you find the back of the periodic table. If it was HCl, it'd be H plus plus Cl minus. If it was ethanoic acid, it'd be a weak acid, so it partially ionizes, so you'd have CH3COH, the reversible arrow would give CH3CO minus plus H plus. How do you describe the extent of a strong acid ionized in water? Remember, a strong acid fully ionizes, so it's 100%. Then I go on to show you here a simple equation to show the reaction between nitric acid with zinc metal. So this one here, you're going to be doing, calculate the number of grams of zinc that would be needed to produce 37.8 grams of zinc nitrate. So they've already told you that they've got zinc there, so the Zn, and they want us to know how much zinc nitrate's formed. This here is Mr. and Mrs. table to work out your moles. So you've got your 2HNO3 plus your Zn goes to give you Zn bracket NO3 bracket 2 plus H2. Keep yourself right into the equation out. Then you do your Mr. and Mrs. Stands for mass, RFM, moles, ratio, same. So we know that there is 37.8 grams of nitric acid. So there's nitric acid there is your ZnNO3, and we're trying to work out how much zinc we have. So the Zn gets a question mark for the mass. Fill in what you know. So you know that there's 37.8 grams of zinc nitrate, so put 37.8 here. Then you work out you calculate your RFM, so Zn is 65, as it tells us there at the top. We've got 2 nitrate and 6 oxygens in total. So we're going to work this out using to calculate relative atomic mass, or the relative formula mass, sorry. So you would do 65 plus 2 times 14 plus 16 times 6, which gives me 189. Divide them together, because going down the way you divide gives you 0.2. The ratio here is 1 because there's no balanced number in front, so 0.2 stays the same. Then you put the same moles across, 0.2, ratio again is 1, so that means there's 0.2 moles. get your RFM number going up the way you multiply, so 0.2 times 65. When you put that in your calculator, you end up getting 13 grams.